Hello, this is a demonstration of multi-perspective neural networks. So on left side, you can see the anchor image. On right side, you can see the following images that comes. So what we do here is we compare the anchor image with the test image that comes. And test images are mostly the following frames that comes after the anchor image. So as you see, there are a lot of objects here, humans, buildings. As the humans move away, we start losing some features, and so our similarity goes down. Okay, we lost the frame, we lost the scenery. Let's just wait for the next one. Okay, now similarity is pretty high. Our objects are right standing here, and we still have the same objects, and walls and these flowers are still on the same place, but we just get closer, so our similarity is pretty high because our objects are still standing on the scene. But when the scene changes, our similarity goes pretty down. Now we have the new anchor image. Again, same objects are on the screen, just scale is different. We get close to some of them. And similarity is going down slowly. But it's also getting high because we also have features that are similar still on the left side, to the similar to the anchor image. Now we have a new scenery. Our similarity value is pretty high because scenery is almost same. Yes, it's slowly changing. Objects are slowly changing, but the objects that we see are almost similar to each other. Same table, same chairs. So our similarity value is pretty high, and we still see that they're human. Uh, okay, now it's a new one. Again, the same. Our scale is changing. Objects are slowly moving, but we have similar objects all the time. So even though the scenery is changing, we have high similarity value. Okay, now we have a new scenery. Let's wait for the anchor image to change also. Okay, this is a bad luck. Yeah, our scenery for the test images, test frames, and our anchor image change at the same time. So we see actually similar values because of these flowers here. Yeah, trees and flowers look like each other, so our neural network is giving high result. Okay, now they look at the same part. Now different part. I will just let you watch the demonstration. Let's just start it over to match the pictures a bit more to each other. And let's say 300. Okay. You see similarity value started pretty high, but it's going low. We have different objects in the scenery. But we still look at the same place with same angle. So we have similar objects as well. Now our similarity is pretty low because test frame has changed. And they are not similar to each other almost at all. Let's wait for the anchor image to be updated. Now our similarity value is pretty high because we looked at pretty similar images. And now we see that it's completely different scene, but our similarity value is not so low. It may be the reason that we still have these buildings, and people on the screen, so it may be catching those features as well. Therefore, similarity value is still around 0.6, 0.7. Now we have even different one, and as you see, there are no buildings here, so similarity value is lower than 0.7. Now our anchor image has changed also. Our similarity value is pretty high, even though our scale is changing for the objects on the frame. Uh, Similarity value was pretty high, so it means that it's scale invariant. Now we have a new test frame. It's completely different than what we have in the anchor image, so as you see, similarity is pretty low. Because there are no trees here, only buildings and people. Now we have some trees, some green, so similarity values start becoming high. Now our anchor image is almost same, so it's slowly changing. We had a tree, now we don't have the tree, so we lost some value in the similarity, but we still have similar objects even though the scale is different. So our similarity value is pretty, it's not pretty high, but it's high. Now we have completely different scenery, but since we have still buildings which are similar to each other, we see that similarity value is not so low. And when object is passing through the frame, as you see, similarity value is going down because we don't have that object, which is that human. We don't have that object in the anchor image. When it passes through, similarity goes high up again. Now our sceneries are almost same, so our similarity value is very high, but it's slowly changing. So this is the demonstration. Uh, I will just let it play some more for you to see how it goes. And just to remind, here is the anchor image, here is the test images. So what we do is basically comparing them with each other with cosine similarity. Again, similarity is pretty high. You look at the similar scene. Even though it slightly changes, we still see pretty high similarity value. It means that we still can catch features even though there is a scale variance. As you see, similarity value is pretty high. It's most probably because of the bricks that located in the both images. Maybe because of the color as well. Okay, our similarity value is pretty high right now. It doesn't go down so slow because we look at almost same images. As you see, there is a change in the scenery. Now they are not same, but they are really similar, and similarity value is representing the similarity pretty well. Now we have completely different scene, and similarity value is low. This looks like a good place, beautiful one. Okay, now we have similar anchor and test images. Our similarity is high, but it's going low. The reason may be that we don't see the sea anymore, and looks like we catch features from sea a lot. But we still have similar objects which are these humans, so since we see them, our similarity value is still acceptably high. And the buildings as well. we have similar buildings in both images. We have humans here. In the test image we have buildings, as you see, similarity value is very high, and if you are careful, this one is more dark image, so even though the intensity of the values is changing, is different, we still can catch high similarity values. It means that model is not only scaling variant but also robust against these intensity changes. You see, it's like almost same. It's pretty nice. And we see human, they are changing, but even though they are changing, they are still human. So we catch similar features. Here, as you see, we have humans as objects. When we lose them, we have a slight decrease in the similarity. It means that our model catched features from humans. Other than that, similarity is very high. It is uh, due to the reason that we still see the same landscape. So similarity is pretty high because of that. As you see, we have new objects which are this human, and they are pretty close, so our similarity value is a little bit lower. Now the anchor image changed, and we lose our features that we get from the human, so our similarity value is a bit lower. Yeah, we don't change much after that. So thanks for watching. Hope you like the system. And that's all. Thanks.